In this video, we're going to compute the slope of a line. The slope of a line is important because it tells us about the steepness of the line and the direction that it's traveling, particularly as we move left to right. The steepness can be determined by the absolute value of the slope. The larger the absolute value, the steeper the line. Whether the slope is positive or negative can tell you about direction. If you consider the example on the left, if we begin at a given point and move to the right, you'll see that the line rises. Versus the example on the right, if we pick a given point and move to the right, you'll see that the vertical height decreases. This indicates a negative slope. There are a few different ways we can consider finding the slope. The first one is to find the vertical change of our line over the horizontal change of our line. An additional way, which is in fact actually doing the same thing but in a numeric fashion, is to take the points and take the vertical change, meaning the change in y's, y2 minus y1, and dividing it by the horizontal change, or the change in x2 minus x1. Let's begin first with this numerical method that we see on the right. We know points come in ordered pairs, x comma y. So let's take this pair of points and consider it as x1, y1, x2, y2. To compute the slope, often thought of as m, we begin by computing the changes in y's first. So 4 minus 1 over 3 minus negative 2, which would be our changes in x. This would result in 3 over 5, indicating a positive slope. Let's look at example B. We would similarly label these points x1, y1, x2, y2. And we begin by computing our changes in y. Negative 2 minus 4 over our change in x. 1 minus negative 1. In this case, we'll get negative 6 over 2. Since we can divide negative 6 by 2, this will result in a slope of negative 3. Since negative 3 has a larger absolute value than 3 over 5, we would expect this line to have a steeper slope, and in addition, as you move left to right, you would expect this line to be falling. Let's now consider finding the slope of a line given its graph. In example A, I'm going to begin first by finding 2 points along this line. Let's say I choose this point, negative 2 comma 1, and this point 3, 4. In our previous example, we've actually already computed the slope between those 2 points, but let's see in fact that it is 3 over 5. Remember, we're looking for our vertical change divided by our horizontal change. In this case, to move between these 2 points, I would have a vertical change of 3 units and a horizontal change of 5 units. Since we know our slope is the vertical change over horizontal change, this will result in a slope of 3 over 5, much like we expected from our previous example. Let's likewise do that with the graph on the right. Let's begin by picking 2 points. I'm going to choose this one. This point is negative 1, 4. And I'm going to choose this point, 1, negative 2. And again, you'll notice those are the points from our previous example. Let's consider the vertical change. Here, the vertical change is downward. We're going to think of that as negative 6. The horizontal change is to the right 2, so positive 2. In this case, our slope would be negative 6 over 2, which is negative 3. So we can see, in fact, that our numeric formula is the same as what we see happening here visually. You'll notice that the graph of A has a slight upward trend, so that is why it's a positive slope, whereas the graph of B has a very steep negative trend.